So this beast right here of a question can be a big challenge if you're not used to interpreting a text, reading calmly. So if you're having a hard time with this type of question, take a breath, slow down, take it easy, make sure that you're able to concentrate and read each sentence carefully. Because one of the biggest mistakes in this type of question is to be unable to set up the equations correctly. So let's read first without doing anything and then decide what we're going to do. First thing the question says is that the sum of three numbers is 16. So there are certain three numbers that we don't know that add up to 16. The sum was twice the first number, 3 times the second, and 4 times the third is 46. So we're doing multiplying the numbers by something before adding them. And the third sentence says that the difference between 5 times the first number and the second number is 31. And then find the three numbers. Make sure to identify which one is the first, which one is the second, and which is the third. Okay, so it just doesn't matter that I give you just any three numbers. I have to tell you which one is the first, which one is the second, which one is the third. So that's pretty important. All right, so let's see how we are going to solve this. Since I have three numbers that I don't know, I'm going to create three variables and I'll name them. X is going to be my first number. Y is going to be my second number. And then Z is going to be my third number. Don't want to use too much space in here because I want to be able to read the statement as I write the equations. So let's color them as well, just to make sure we are not lost. So the first sentence says that the sum of the three numbers is 16. So that means if I add the three of them, I get 16. So that's what the blue sentence says. Pretty simple. Now for the second one, I have to be a little more careful because like I said, I'm multiplying the numbers by something before adding them. So we're finding the sum of twice the first with 3 times the second and 4 times the third. And the result is 46. So that's the second sentence. Pause this, make sure you understand, read again if you need, but this is what it says. And then finally, we're saying that the difference, so things are changing a little bit now. Difference is subtraction, right? One minus the other. The difference between 5 times the first number and the second number is 31. So only the first and the second are involved. Okay, so 5 times the first number minus, because it's the difference, and the second number equals 31. So now we have very well color-coded equations that correspond to each of those sentences, and all we have to do is to find each of the three numbers, x, y, and z. Once I found x, y, and z, I don't have to further identify which one is first, which one is second, which one is third, because I've already done that. If you prefer, you can use letters A, B, and C, but going alphabetically, first, second, third is a good idea, just so you don't get confused when writing out the equations from the sentences. But all right, once this is done, all we need to do is to solve a linear system, and this could also escalate if you're not used to it. A 3x3 system can be solved in several different ways. I'll use the most straightforward way that I see here without, resorting to the higher technology like matrices or anything. I'll try and solve one of the equations. So I'll number them. That's always a good idea. You can use A, B, and C if you want. But I'll number them 1, 2, and 3. And then I'll use equation number 3 to solve for y. So 5x minus y equals 31. If I move the y over and then move the 31 over, I get the 5x minus 31 equal y, so y equals 5x minus 31. So what I'll do next is I'll take this equation and I'll substitute it back to each of the two equations 1 and 2. That way I won't have any y's anymore, and I will turn equations 1 and 2 into a linear system of two variables only x and z be involved. So that's going to make my life a lot easier because I'm more familiar with solving 2x2 systems of two variables and two equations. So let's go. So I have x plus y. So instead of y, I write 5x minus 31 plus z equals 16. So that turns into a 6x. This 31 I'll move over. I'll keep the z right here. And 16 plus 31 is 47. So that's an equation that only involves x and z. And then I'll go to equation number 2. And wherever I see y, I'm going to write 5x minus 31. So 3 times 5x minus 31 plus 4z. Careful here because I just wrote a 47, right? If your handwriting is a little confusing like mine can be, you can confuse this with a 47. So sometimes when I'm afraid of that, I'm going to write my z like this just to be safe, but I'm okay. You can see this is a z, and that equals 46. So distributive property, 2x plus 15x minus 93 plus 4z equals 46. So group the x's, that's 17x, and then plus 4z, and then this number is going to go all the way to the other side, and the right side will be 46 plus 93. I think that's a 139, but I'll double check because I want to be safe. If that's a test, I don't want to mess it up. So that's 139, as I thought, and that's my second equation. So now I need to group these two together, and then I'm solving an equation that says 6x plus, or a system of equations that says 6x plus z equals 47 and 17x plus 4z equal to 139. So this is a system of equations that only involves two variables, so I'm more familiar with how to solve this. So I'm going to solve, renaming this equation 1. I can see that z is 47 minus 6x. I substitute back into equation number 2. So 17x plus 4 times, and instead of writing z, I write 47 minus 6x. And that equals 139. Distributive property, 17x. Careful with the bookkeeping here. Almost made a mistake. So I'm multiplying 47 times 4. So what is that? 28. Is that a 188? I think it is. I'll double check just to make sure. That's correct. And then 4 times 6 is 24x. That is fine. That I don't have to double check that. And that is 139. So group the x's. 17 minus 24. That will be a negative 7x. And 139 minus 188. That is a negative 49. So that looks beautiful because now I can just divide negative 49 by negative 7 to get 7. So that is the first number. I had 3 to find, and that's not just a third of the way there, that's almost all the way there, because all I need to do now is start backtracking. So I backtrack here. So remember that z was 47 plus 6x, or minus 6x rather. I know x now, so z is 47 minus 6 times 7, yeah, which is 42. That's a 47 minus 42, so z equal to 5 is the third number, right? Not the second. It's important to remember. That's why we gave them names. And then I can backtrack all the way to the purple equation that I had. Y equals 5x minus 31 to find y. So 5x minus 31. So y equal to, x was 7, so 5 times 7 minus 31. So that is 35 minus 31. So that is a 4. I could also have gone to the first equation that says the sum of the three is 16, right? That would have given me y equal to 4 as well. But as long as I can show my work properly. So these are the three numbers. Make sure you're able to organize your work carefully, neatly when you're doing this type of question. Right? Numbering the equations is always a good idea, just so the reader knows what you're doing. And this is how you solve it. Pretty cool, huh? So the numbers are in order: 7, 4, and 5. 7, 4, and 5. 7, 4, and 5. That's what it is. Pretty cool, huh?